In the previous video, we have seen what people want and how they want to trade one good for another to stay basically equally well off. In this video, we'll continue the building blocks of our model and we'll analyze not what people want, but what they can actually do. So let's go back to our production function for grades. A person has 24 hours per day, right? If they don't work at all or study at all, they will work just 0 hours. Consequently, they will have 0 success in their exams and will have 0 grade points. However, they will have 24 hours of free time per day. On the other hand, if they work 24 hours, they will be able to achieve the maximum grade of 90 points. However, this means they will have 0 hours of free time. Notice that this production function for grades had hours of study on the horizontal axis, which was an input into the production process. But we can represent what is feasible not only in terms of hours of study, but also in terms of free time. This is exactly what we're doing here in this graph, in this figure. Notice that the horizontal axis now represents a mirror image of working hours per day. It represents the free time a person has. So if a person has 0 hours of free time, they'll be able to achieve the maximum grade of 90. On the other hand, if they have 24 hours of free time per day, they will have 0 working hours, and then they will have 0 grade points. This is exactly the same logic as before. The only difference is that we have on the horizontal is what we have on the horizontal axis. Before, we've had hours of study. Now we have hours of free time. And because the hours of study run in the opposite direction to the hours of free time, the two figures are a mirror image of one another. So if you plot what grade you can achieve with a certain free time, you get to see what is feasible to you. In other words, you get to know your feasibility constraint. The feasibility constraint does not tell you what you want to consume. It tells you what you're able to consume. In essence, it is the constraint you're working with when trying to figure out how much free time you want to have given your own constraints. So for example, with 11 hours of study time and 13 hours of free time, you can achieve a maximum grade of 84, like before. So the feasibility constraint separates what is feasible from what is not. For example, you may want to have a grade of 70 and work only 4 hours per day for this grade and have 20 hours of free time. But it will not be possible. It is outside of your feasibility constraint. However, you can definitely get a grade of 57 points if you work 5 hours per day and enjoy free time of 19 hours per day. Notice also that if the consumer, or if they choose to sit inside the feasibility frontier, the consumers are wasting resources. Take point D, for example. Point D corresponds to a grade of 70 and 14 hours of work per day. But notice that you can get a grade of 70 with only 7 hours of work per day. Why? Why would you work 14 hours to get the same result you can get in 7? It's not rational. Reasonable people don't act like that. Alternatively, you can also think about it this way. Point D corresponds to 14 hours of working time and only 10 hours of leisure. But with 14 hours of study, you can achieve much more than a grade of 70. Why would you settle for 70? It's not rational. You're wasting resources. So People typically choose some combination of goods sitting on the edge of their feasibility frontier. Only then they can be sure that they're not wasting any resources. So to sum up, the feasible set represents all the combinations of goods we care about, which we as consumers can achieve. The set does not tell you what is desirable, however. The set tells you just what is feasible. And even though all combinations are feasible, consumers prefer to choose something on the frontier itself, because only then they know they have not wasted resources. The feasible set allows us to look into another important trade-off in our choices, the trade-off between what is feasible. Notice these 2 points, A and E. The difference between them is 1 hour of work and a few grade points, and both are feasible. So let's move the consumer from point A to point E. What happens? The consumer gets 1 more hour of free time. That's the obvious thing that happens. But he's not able to achieve that without sacrificing a few grade points. In a way, the price of an hour of extra time is embedded in the feasible set. The consumer pays for an hour of extra free time with 3 grade points. In other words, if he wants an hour of free time, he will have to forego the benefits he gets from 3 additional grade points. We say that the foregone benefits from choosing to have something are called opportunity costs. Of course, as you move along the feasible set, the opportunity cost will vary. This is because when you have worked fewer hours, you're less tired and more productive. Thus, you can produce more grade points with an hour of studying. This is the case with point C. Getting an extra hour of free time when you have worked so little costs a lot of those grade points. However, as you move up along the feasibility set back to point A, you discover that you are tired and less productive. So whether you work an hour more or less does not make such a dramatic difference in your grade points. As a result, getting an extra hour of leisure is relatively cheap in terms of grade points. In the jargon of our profession, when you have a lot of some good, the opportunity cost of giving it up is relatively low. Let's think about the slide between points on the feasibility constraint. As I slide down from point A to point E, I notice that my opportunity cost rises. At the same time, the feasibility constraint becomes steeper. Therefore, the slope of the feasibility constraint reflects the opportunity cost of my free time. But the slope tells you a bit more than that. It tells you how do you transform free time into grade points at each level of free time. So let's summarize. The slope of the feasible frontier is your opportunity cost of free time. But the same slope tells you how you can produce grade points out of free time. That is, it tells you how you can transform free time into grades by working more. It also tells you that you can potentially get more free time, but to do that, you need to sacrifice a few grade points. That particular quantity of the grade points you need to sacrifice to get 1 more hour of free time is what we call the marginal rate of transformation. Geometrically, the sacrifice is presented by the slope of the feasibility frontier. A few of you will ask, what's the difference between the marginal rate of substitution and the marginal rate of transformation. Notice that the marginal rate of substitution was the amount of goods or services the consumer is willing to sacrifice to get a unit of the other good, and at the same time stay equally well off as before. It was embedded in the slope of the indifference curve. Now, this concept, the marginal rate of transformation, does not tell you anything about the wills or desires of the person. It just tells you what is technically possible, what is feasible. In the next video, we will combine what the consumer wants with what is technically feasible to achieve. By doing so, we will arrive at one of the crucial points in this course, a point which represents the best the consumer can get given their constraints. So, next video is key. Keep watching.